Okay, so today we're starting a new chapter. 6.1 deals with something called scatter plots. How many of you, when you hear the word scatter plot, you're like, yeah, I'm not really sure what that is? Okay, so it's kind of a new concept. You might have seen them before, but just not really known what they were called. Okay, anyway, so we're going to learn what they are today. A scatter plot is a graph that shows the relationship between two categories of data. So you're going to see tables of information, and it's comparing two categories of data. That'll make more sense in a minute. There are several things that we can look for and identify with a scatter plot. One of them is called an outlier, and these are values that are far outside the pattern of values, or how the values are trending. Gaps are large spaces between values. Clusters are just basically where data is gathered around a specific value. So the good thing about these terms is it sounds exactly what it means. When I hear cluster, right, I know that it's things bunched up together. When I hear gap, I know that it's a gap between values. So that does make it easier to remember which one is which. All right. So here's our first example. All right, and we're always going to have this kind of table of values to work with, and this really helps us figure out how to set up our scatter plot. Now, these graphs, they look a little different, the graphs that I'm giving you, because they're not numbered. They're not numbered anymore. And here's why. Because depending on the data that the table is giving you, it's going to completely change how your X and Y values need to be set up. It's going to be different on every one. So there's no way to basically just have a set graph with set numbers, okay? So let's look here and see what the topic is of this problem. It says the table shows the ages of 10 adults and the number of gigabytes of cell phone data used by each adult in 1 month. Make a scatter plot of the data and then identify any outliers, gaps, or clusters. All right, so what I'm going to do is go over here to this table. The first category, we're going to keep it real simple, and the first category will be my X category. The second category will be my Y category. You can see that I just wrote in the X and the Y up there in the red headers, okay? So that's my X and my Y. So the two values together will make up an ordered pair. Well, the first thing we have to do is we have to decide what values need to go on the x-axis on our graph. So we look at the range of values that we have here. Do you think I need to go by ones on my x-axis? Would that be practical? Even twos? Okay. So, but I'm also on the flip side not going to go by 100s either, right? So what do you think? What do you think should be my intervals?
3.
3 would still be probably small. I would say 5 or 10. 5 or 10. So what I'm going to do is I'm going to go by 10s, but I'm going to skip every other one. So what do you think the one in the middle would be? It would be your 5s, your in-betweens. So I'm going to go 0, then I'm going to skip 1 and go 10, skip 1 and go 20, skip 1, 30, 40, 50, 60, and 70. Do I need to go any higher than 70?
No.
Okay, I don't think so. Looks like the oldest person is 65. Okay, now let's talk Y values. Should I go by 10s on my Y-axis? No, because now my Y values are completely different. So you see, that's why we have to leave these blank. Okay? I want to go by 2s. If I go by 2s, I'm only going to have literally like 2 numbers on there. Even to go by 1s, there's just a lot. I would go by half. Okay? So every other, you could go by 1s and then just do every other. Okay? So this first one would be half, skip 1, skip 1. We could do it that way. All right, so then those ones in between are our halfway. Yeah, we could do that. Okay, so now that we have these intervals set up, and guys, if yours are a little different, like if you went by, halves every other one or whatnot, that's okay. That won't be wrong. Okay. So now that we have those set up, now we need to come back over here to our table. And remember, each pair makes an ordered pair. So the first one is 37 and 3.2. So I would follow the age over to 37. That's just a little past the 35. And up to 3.2, which would be right about there. Okay. Now, again, we're not going to be, maybe yours would be a little tiny bit higher over to the side. We're not too worried about it. Now, if your point is like way over here for that point, that's a problem. You won't need a ruler for this one, but maybe for 6.2. All right. So now let's do our second ordered pair, 30 and 3.3. All right. And let's just get, let's get these points on the graph. 30 and 3.3. 32 and 3.1, 65 and 0.9, 53 and 1.8. Are you guys following along with what we're doing?
Yeah.
Is this making sense?
Bob just put it on the grass.
Okay, let me just get the rest of the points on here now. 25. Up 3.5. All right, from the looks of things, it looks like you guys are doing well. 59 up 1.3. Um, 30 up 1.8. 50 1.9. And 34, 3.3. Okay, stop talking. Okay, all right, so I've got mine on there. Is everybody else pretty much done? Okay. All right, so now that I have my scatter plot, I have all the data points plotted, I need to answer these questions. Do you see any values that kind of are outside the rest of the trend of values? So we definitely have a trend going on here. Do you see any ordered pairs that kind of fall outside that trend? Mason?
65.9.
No, I mean, even though that one's at the bottom, it's still following the pattern.
Oh, I know.
I think I got it.
Connor?
30 and
Yes.
1.8.
Yes, this guy down here, okay? He falls out. So I see that my pattern, we're going to talk about that pattern in just a minute, and actually tomorrow in 6.2 we'll talk about it even more. But that guy down here, 30 and 1.8, that's my outlier. All right, now, think about what that means. How old is this person?
30.
30. And how much data is he using cell phone?
1.8.
1.8. And we're saying that's significantly lower than the average. So what would you say about that person? About their lifestyle, their life?
She's a
They
youngest.
live life to the fullest.
Why would you say they live life to the fullest?
Because they're not.
They don't
always
use
on
their phone.
They're not on their phone. So maybe they're engaging in meaningful relationships. They're out having coffee and they don't have time to be on their phone, right? So you see, just from a dot on a graph, there's a lot of insight there, isn't there? Okay? That you can actually make conclusions. This is what businesses, this kind of data, businesses live and die on this kind of data. Okay? When they collect this data and they're analyzing it, they use it to forecast what types of advertisements they need to be doing. For example, do you think this company, if this was a cell phone company, do you think they would want to advertise towards maybe some of the older generation? Look how much they're using data, right? They probably want to focus more on the people who are using a lot of the cell phone and developing apps and things like that. So that's just one small example of how information can really help companies. All right, so gaps. Do you see a gap? Like here we have this data and then we have nothing.
Yes.
Do you see a gap going on here?
3.
I see a gap between, and usually we'll describe gaps in clusters using the X values, okay? So what X values do you see like no information? What's the range? From,
45?
yeah, you're close.
45.
It's in this area right here, right?
Yeah.
There's nothing. So that's about from 37 all the way up to 50. From 37 to 50, 37 years to 50 years, I have no data at all. Now, how many people did they survey? Only 10, all right? So if they really want more accurate information, they should probably ask more people, all right? Or go back and try to find people in that age range. Because maybe the 37 to 40-year-olds, maybe they're like way up here, and that would be helpful information. What about clusters? Do you see any clusters?
Yes.
Yeah, definitely. Where, Josh?
20, and around 30.
Yeah, these late 20s and early 30s, right? So I would say probably between the ages of maybe 25-ish to 37-ish. Okay? Now, again, if your description is a little off, that's okay. All right, but we definitely see a lot of the data clustered in this late 20s to early 30s age range. All right, so don't worry if you think, oh, well, I would have said, 32 years old or something like that. We're just kind of looking for a range. All right, so as long as you don't say 55 to 60, we're okay. All right. Okay, how do we do on example 1?
I like it.
Did okay so far?
A little bit.
All right, so if you're really drawn to this kind of information, you might be kind of like a data person, like a business analyst type career. They make a lot of money. Okay, so just a little tidbit of information there. So identifying relationships. So this should look familiar to you because from left to right, okay, how are the values trending?
They're going up.
They're going up, so that's positive. From left to right, when they go down, that's
Negative.
negative. When it's nonlinear, it's kind of like a U shape. And when it's no association, it's just all over the place. Okay? This is very similar to slope, right? From left to right, it's going up. From left to right, it's going down. I want you to go back and look at example 1. What kind of relationship do you see there in example 1?
Negative linear equation.
I see a negative relationship, right? Okay, so how could we put that into a sentence? I'm going to go back. How could we put that into a sentence? If I wanted to describe the relationship, I'm going to ask you to do this, okay? If I wanted to describe the relationship in a sentence, you're describing how the X and Y values relate. This is what you would say. As what did my X value stand for?
The age of the
As age increases, what did my Y value stand for?
gigabytes used.
Okay, cell phone usage or gigabytes. Cell phone usage decreases. All right, so a really popular saying for older people is, back when I was a teenager, right?
Yeah.
Not even old people. I even say that. I'm only 32, and I'll say, man, back when I was a teenager, we did instant messenger. Like, we didn't even really have texting until I was, like, more middle school.
MySpace.
Okay? Yes, MySpace. You laugh. I had a MySpace page in college. I had that background music and, all that, like when you go to the page and you can customize it. I remember dial-up internet. Does that even mean anything to you guys?
No.
Okay? So what does this tell us, okay? As age increases, cell phone usage decreases, it might have something to do with advanced technology, okay? That, you're just at the age where you'd rather have a flip phone and use what you know, right? My first cell phone, like you pulled the antenna up. A cell phone, you would pull the antenna. And Miss Warpaw can hear me right now. She probably had one of those too. Okay, so like it was, it was very popular. I mean, and it was, you were cool if you had a cell phone at 13. Now, like, kids are like 6 years old and having
With
cell
iPhone
phones.
11.
As soon as they can read, they're getting cell phones.
No, I seen the video
Right?
about iPhone 11.
Because it is very convenient. I mean, my daughter's almost 6. She's starting to read, but she's like sounding everything out. Bat, Yeah, it's interesting. I'm rambling. I normally don't ramble on my YouTube videos. Okay, here we go, guys. Yes, that's on my YouTube video. Okay. No, I can't edit it. Oh, well. So people are going to hear my life story. Okay, so identify the type of relationship. All you need to do here is tell me, is it positive, negative, or nonlinear, or no relationship, and then put it into a sentence, okay? So that's all you have to do. So can we all agree what kind of relationship is happening here? Positive, okay? But that's not my whole answer. Now I need you to put it into a sentence just like we just did with the cell phone example.
Is this still cell phone? Oh, no.
No, this is a different one. So look at your categories to know how to write your sentence. I want to see who can get it. Okay, Connor, how did you describe it?
I said the scatter plot shows that price increases as TV size grows.
Okay, price increases as TV size grows. The only thing I might switch on that is just write my X value first, but he's fine the way that he said it too, okay? As TV size increases, price
Goes up.
increases, okay? Price increases. And doesn't that make sense? I mean, of course, in all reality, we would love for the bigger the TV, the less money it costs. But that's just not how it works, right? It doesn't really cost the company that much more money to build the bigger TV. Think about it, like materials-wise, right? But they can still sell them for so much more money.
They still have to make it 4K.
And that's another thing. Like literally not even 10 years ago hardly, you were paying double and triple the amount of money for the same size TVs and actually less technology. So it's crazy how the cost of TVs has gone down. I mean, I remember paying $1,200 for a 42-inch TV. On Black Friday this year, a 42-inch TV was like $200. Like it was just cheap. Isn't that crazy? And $1,200 back then was like a deal. We had to save up our money. I mean, because we were young.
But
And
now we got phones now that got Netflix.
yes. I mean, iPhones. Yeah, those came out like 2008ish, roughly 2010. Okay, so this will be the last problem we do. We're gonna do one more scatter plot. All right, we're doing good on time. The table shows the amount of fat and the number of calories in 12 restaurant sandwiches. How many grams of fat do you expect in a sandwich that contains 650 calories? So what you're going to do is, there are no sandwiches in here that are 650 calories. However, you can plot them on a scatter plot and then kind of estimate based on which ones are kind of close in value. All right, so the first thing we're going to do is establish that fat is my X category and calories is my Y category. All right, and based on the values here for the grams of fat, am I going to go by 20s? No, that's way too big. Am I going to go by 1s? No. I would say 5s, okay? Now, we're going to do the same thing we did on the last one. We're going to skip 1 and do 10. Skip 1, 20. The ones in between are your 5s. 30, just because it gets really...
Well, you said 10. I thought you said do 5.
Well, I basically am, because the blocks in between are my 5s. Okay, so if I did every single one, I would be going by 5s. All right, but since I'm skipping...
Is the Y gonna go by 5?
No, I think we should go by 2.
Now the Y's, woo,
So you go by
yeah.
100.
I need to go by hundreds, okay? But what I'm going to do, I'm going to go by hundreds, but I'm going to skip every other one. Okay, so skip 1, 100, skip 1, 200, 300, 400. So the block in between is your 50s.
We just go up to 700?
Yep. Yeah, because is there anything over 700?
Yeah.
Oh, yeah, there is. Oh, man.
740.
Well, that's okay. That one will just go a little bit off.
And 790.
Yeah, that sandwich you want to stay away from.
Rotter.
Right?
Rotter.
Okay.
Rotter.
Because, I mean, look. I mean, 790. Yeah. Anyway, that's kind of high. All right. Shh. Quiet, guys. Let's go ahead and get these points on the graph.
I'm gonna try my best to do this. These are different.
All right. 17 and 400. So I go over 17 and up 400.
You gotta really
Right about here. All right. You see how I did that?
You gotta concentrate on these lines.
Yeah, you do. I mean, you might want to like kind of use your finger to kind of follow the lines. All right, over 12, up 470.
What kind of sandwich are you eating?
Subway sandwiches hit.
Oh, it's that. They got that.
29, 540.
Can I eat it?
26, 510. 10, 420. All right, so I'm going to walk around and kind of just see how you guys are doing, and then we'll finish this
I
up.
get it a little better now.
All right, so I'm on 42,
1, 2, 3, 4, 5, 6.
up to 740. Yeah, it's like so easy to lose your line.
Yes.
30 and 600.
Man, this is so
You tried? Did you just say you tried?
Yeah, I said I tried.
33 up. Don't want that point there.
This is much easier.
I told you to hang on.
I think we needed a change of pace. Like chapter 5 was so heavy.
Yes. It's better than last
There
year.
was so much that you had to memorize.
What?
I know.
What is so?
All right, 44 and 790. This is the one that kind of goes off.
This is easier than 5.
Oh, that's so
22 and 510.
It was.
I think I did good.
It's just, I think I got substitution wrong. Everything else I think I got right.
The second-
39 and 610. Are you guys done?
No. No.
Grayson, you're not done. Grayson, glorious. Grayson, glorious.
And 28 and 510.
Can you get some new shoes from Christmas?
Okay, so what do you think, guys? Are there any outliers really? No, I don't see any. Now, an outlier, that's gonna look like this, like way like over there. Okay,
No.
so there's no outliers. I don't really even see any gaps. Again, I'm looking for gaps on the x-axis, not necessarily the y-axis.
It's a
Okay,
little gap between
so
30 and like.
But that's
yeah, maybe but that's.
No, it's not.
No, there's not really a gap. Cluster, yeah, maybe like in the 30s, like
30,
kind of,
40.
yeah, like in that area. All right, but that's not actually what it's asking me. It's asking me at 650 calories, okay? So at 650, so somewhere in this range right here, all right? How many grams of fat would you expect based on how these values are trending? What do you think?
It's gonna be difficult.
All right, I put a couple scatter plots on there, I think. All right, so what do you think? 650 calories. Do you see any sandwiches that are pretty close in value to 650?
Yeah, 60 to 40.
640. And how many calories did that have?
33.
Or I'm sorry, fat. Yeah, 33. And then what's the next one above 650 that's closest? I'm looking for like a 700-ish.
740.
Okay, and that one's 42. So it's got to be somewhere in that range and probably closer to 33, wouldn't you think? Because 640 is like really close. So what would you say? What would be your estimate?
34.
34, 35, 35-ish. I'd probably accept anything in the 35 to 40 grams of fat range. Okay? Now, that's not a specific answer. That's just kind of like a projection or an estimate. All right? So, yes.
Is like 740 calories bad?
That's pretty bad. So, like, on average, the average American, I think, is supposed to eat about 1,500 calories a day. And that's like 3 meals and 2 snacks. So, if one sandwich is literally half that, that's probably a lot. And you should not be eating like once a day because that really just like stops your metabolism. If you're eating small amounts throughout the day, that keeps your metabolism going. All right, can anybody tell me what kind of a relationship this is?
Positive.
Right? Okay, so I would say it's a positive relationship. Can anybody put that into a sentence? Put it into a sentence.
Wait, what'd you say?
Can anybody put the positive relationship into a sentence? Like we said, TV size increases and price increases. Josh?
As fat increases, the amount of calories in the sandwich also increases.
Yeah, that's perfect. And isn't that true, right? Like, I kind of wish it was like, because the fat usually is what makes it taste good, you know, some of that flavor. As the grams of fat increase, the calories are going to increase. Yeah, have you ever had a burger from like M Shack or Five Guys? Don't even look at the menu, okay? Those calories are like literally an entire day's worth of calorie in one sandwich. It's awful.
Yeah, do y'all eat burger
Okay?
Burger Fi is.
All right. So, yeah, that's everything for 6.1. Just kind of looking at this data and doing those interpretations.